Now, in this problem, we have 3-point charges, and we want to know the electrostatic force experienced by Q3 due to Q1, which is 1 nanocoulomb, positive, this is Q1, Q2, which is negative 3 nanocoulombs, Q2, and then our Q3 is this one. Now, let's go back to the problem. The problem says the electrostatic force experienced by Q3. So again, guys, we're just looking at the experience, the force experienced by Q3. Okay? So the first one is, let's solve the force experienced by Q3 due to 2. Okay? So I'm just looking at the force experienced by this. So let's compute for the force experienced by 3 due to 2. So we have this formula, K, which is constant, that is 8.99 times 10 to the 9 newtons meter squared coulomb squared divided by coulomb squared. Let's use this formula. Q3 is this one, and then Q2 is this one. The distance between them is 20 centimeter. 20, remember, 20 centimeter is times 10 to the negative 2. So I hope you still remember meters. Okay, and that is equal to this one. But remember, we can also write this as 1.35 micronewton. Okay? I hope you still remember that we can write that into its component form. How did I know that that is its component form? I didn't use cosine and sine there. I just think about this way. This is Q3 and this is Q2. Since this is the relationship, the Q3 and the Q2, we know that Q3, what will be the force felt by Q3? The force felt by Q3 is attraction because this is positive and this is a negative charge. Therefore, it's going to the south. And that is to a negative y-axis, and that means to a negative j hat with a 0 I hat. So I hope you understand why I have this component form. Now, let's solve the next one. And that is the force experienced by Q3 due to Q1. But before that, let's compute for the distance between them. If you are still familiar, I will use the Pythagorean theorem, the 20 centimeters squared plus 20 centimeters squared. Square root of that, you will have C is 28.28 centimeter. So that's the distance between Q1 and Q3. So let's solve that. Okay, so let's compute for Q1. For Q1, force experienced by Q3 due to Q1, the distance between them is this, using the Pythagorean theorem. And now, if you solve it, we will have this one, which is 0.00, I think that's 6 zeros, 225. Now, if you write it in its simplest form, the answer will be this one. And you will have this answer, and we can also write it in this form. But the problem is, we should know the component form. So let's talk about the I hat and the j hat. Now, if we solve this problem, what is experienced by Q3? By Q3 due to Q1. Is it attraction or repulsion? Since they are both positive, it's actually repulsion. So Q3 will go to this side. Now I will just write an x and y axis so that you'll know. Here in this side, the negative is x and the positive is y. Positive is y. Now what is the angle? If you observe, this is actually an isosceles right triangle. That means this is 45 degrees. So the angle between them is 45 degrees. So it means that we expect a negative x and a positive y. with an angle of 45 degrees. Now, if you solve that, okay, for the negative x, we use 0.23 cosine 45 degrees. It should be negative, guys. Cosine 45 degrees. That will be our I hat. And then a positive 0.23. And I will use sine here. Sine 45 degrees. Now, if I solve that, that would be, okay, so that would be 0.16, and I will have this one. But the problem is asking for the net force. So if you're talking about the net force, it would look like this. This one and this one. And then if you're looking for the net force is adding the x and the y component form of the two vectors, the x and the y component for, or what we call the j hat and the I hat of the forces. If we add this one with this one, we have this, and then if we add this and this one, we will have this, and this is our net force in its component form. Now, how do we confirm that that is correct? So let's just talk about our Q3. What is the force experienced by Q3? Actually, Q3 is dragged down because due to Q2. It's a law of attraction between two different charges. Now, it's also repelled by Q1. Q1 is here. So, it's also repelled by Q1 because this is positive and this is positive. This one is negative. So, the net force that you expect actually will move somewhere here, which is in the XYZ plane. That is a negative X and a negative Y. Then as you observe in our problem, both of them are in a negative Y and in a negative X. So that is our final answer. This is a little bit complicated, but I hope this lesson helps.